Hello and welcome to our SENG 637 Assignment 5 demo where I, Bhavya, together with Drew, Michael and OK will demonstrate software reliability assessment done using reliability growth testing and reliability demonstration chart.
Hi, so Michael here, and I'm going to talk about the tools as well as the model that we have chosen for reliability growth testing. So first of all, we have tested the various software recommended, and we ended up using C-SFRAT as we found it is the easiest for us to view and do comparison of all models at the same time. Now, with the software in mind, we then first loaded our failure data and choose all of the hazard functions right here, and then run the estimations by also choosing all selected covariates in order to compare the models and which one fits best to the failure data. So as for comparing, we would then output it into a CSV file. And then we basically use the parameters AIC and BIC to choose our models, in which the ones with the smallest AIC and the BIC numbers are chosen. So when we sorted, we found that the discrete variable type 3 and the geometric models with only the F covariate would perform the best in terms of the failure data provided. So then we also tweak the settings after we get the models chosen of the subset failure data as well as the effort per prediction interval for covariate F to see which subset of ranges gives us the best predictions. So as you can see here in the end, we found that the subset data of the first 21 intervals and 20 efforts per interval for covariate F proves to have the best prediction results. So as you can see here, this is when the models start to predict from the 21st interval.
For software, in making decisions based on reliability growth testing, for a given failure count, testers pick a target failure rate or a target mean time to failure that they consider acceptable. One advantage of reliability growth testing is that it allows the tester to pick the failure behavior using a set of predefined models. Using parameters like the AIC and the BIC that Michael just talked about makes it easy to compare these best models. Although one drawback with the reliability growth testing is its dependence on the range or subset selected for prediction. Things like distortions in data could affect the accuracies of predictions. Another downside in reliability growth testing is it doesn't take into account the developer's risk factor. It only measures acceptance using the target failure rate or the target MTTF.
Hello, this is Drew, and here I'll be talking about the RDC graph. So this is the original failure data we were provided, which was the failures per interval. We needed to convert that to time between failures so that we could plot it on the RDC graph. So we've done that here. As you can see, we had 92 failures over the 31 intervals. So we can plug those numbers into the RDC graph. We used the default parameters for discrimination ratio, developer risk, and user risk of 2, 0.1, and 0.1. And then we got this graph here. So this is the 92 failures per 31 intervals. And as you can see, it goes immediately into the reject region as the MTTF is too high. So we reduced that until we got this graph here where it almost goes into the reject but doesn't, and then continues to the accept region. So the failure intensity for this was 675 failures per 31 intervals, or an MTTF of 0.046. For the next graph, this is double the minimum MTTF, and as it does not meet these requirements, it goes immediately into the reject region. This is half, and it goes immediately into the accept region here.
The reliability demonstration chart needs interfailure time and target failure rate or MTTF of the SUT. One of the advantages of RDC is that it is time and cost efficient as very little processing of data is required. Another advantage is that RDC makes it easy to determine whether the SUT should be accepted, rejected, or more testing is required. The disadvantage of RDC stems from this very advantage that it cannot calculate the exact quantitative value for the reliability of the SUT. Both RGT and RDC are used to get the reliability statistics of the SUT. However, in our opinion, RGT is optimized to make reliability predictions based on the existing failure data, whereas reliability demonstration chart is optimized to check whether the target failure rate is met or not based on the existing failure data. That's all for this presentation. Thank you for listening.